The next factor that affect the rate of the chemical reaction that we are going to discuss is the pressure. So concentrate yourself. Pressure changes only affect the speed of the reaction where gaseous reactants are involved. So this is the first point that you should remember, that reactant particles should be in gaseous reactants. So then the pressure will affect. Increasing pressure increases the speed of the reaction. So the original idea, which is involving again and again, that if the particles of the reactants come closer by any way, the way may be like increasing the temperature, because increasing the temperature will make the speed of the reacting particles faster, they will collide more frequently. By increasing the pressure, by increasing the concentration, like whatever the way, the main idea is if the particles of the reactants come closer by any way, there will be more chances of the collision, there will be more chances of the successful collision. So the rate of the chemical reaction will be increased. So this is the main idea, and you will read this. So this main idea should be in your mind, because you have to make this story around this original idea. So look now, increasing pressure increases the speed of the reaction. A higher pressure, the number of the gas particles per unit volume or the gas concentration increases. So definitely when you will increase the pressure, there will be less space available for the reactant particles. Now reactant particles will come closer, more frequently collisions will be there, rate of the chemical reaction will be increased. So this is the story. So look now, the reacting particles are crowded into a smaller volume, enabling the particles to collide more frequently. The total number of the collisions per unit time increases, and hence the frequency of the effective collision increases. Hence the speed of the reaction increases. So this is the story. Look now, here are two syringes, or you may consider it one syringe. So when the syringe was in this condition, here are the reactant particles. So look now, the reactant particles are far away from each other because more space is available. But when we push the plunger like this, definitely there will be less space available for the reacting particles. They have come more close to each other, there will be more collision, there will be more successful collision, and the rate of the reaction will be increased. So look now, here is a video that will make your concepts more clear.
Pressure is another variable you could consider. What do you think the effect would be if we had a gas?
So look now, in the beginning, this was the space available for reacting particles. So whatever the rate of the chemical reaction in this state was, when we push the plunger, there will be less space available. Look now.
A gas, and we compress.
So look now, here is less space. Particles will collide more frequently, and speed of the reaction can be will be increased because reaction will take less time to complete. Then more pressure will be built.
We increased its pressure by squashing it in.
Look now, they are coming even more close to each other. So this is the simple way.
Into a smaller volume. That would mean that the particles that are vibrating around would be confined to a smaller space, and so they'd be more likely to hit one another. Conversely, we could ask ourselves, what would the effect of expanding a gas be, and so decreasing its pressure, giving them more space to bounce around, and therefore.
And the reverse is also applied. So when we decrease the pressure, there will be more space available. There will be less collision because the particles will be far apart from each other. So this is the simple idea. And ATP paper this question may come into the ATP paper also. So likewise, the rate of the chemical reaction can be obtained by by recording the time. So look now, when pressure is this, so here is the pressure that is measured, that is 13.4 atmosphere. Whatever the time that is taken to complete the reaction will be recorded. This will be the first set of the values. Then pressure will be increased or decreased.
Of course, it will be less chance that they meet one another. The amount would be.
So look now. Now the pressure is 43.4. Whatever the time that is taken, that will be recorded, and up to so on. Then these points of the sets will be plotted on the sheet of the graph paper, and then a line of the best fit will be plotted. Line of the best fit is a line which passes through maximum of the points, and in that a way that the points above the line should be equal to the points below the line. That is actually a line of the best fit. So more steep the gradient, more steep the slope, that shows the reaction is faster, and less steep the slope, that shows the slower the reaction. So this is the question that may come in the alternate to practical question as well. So moving further, here is an exam tip for you students. Higher pressure is commonly used in industrial processes to make reactions go faster. For example, in the Haber process, a higher pressure is used to produce a larger amount of the ammonia at equilibrium, and it also makes the reaction go faster. So this process is used in industries to make the reaction faster. And here are some questions. Nitrogen and hydrogen react in a closed vessel. In this process, this is the process that is called Haber process, that is normally used in industries to make ammonia. How do the speed of the forward and reverse reaction change if the process in the vessel, pressure in the vessel is increased, but the temperature is kept constant? So listen, one more point that is very important. When the speed of the chemical reaction increases, so try to understand and keep this in your mind. The speed of the forward reaction as well the speed of the reverse reaction also increases. So this A point will be applied when pressure is increased. Answer A is when pressure increases, the reaction in both direction will also increase. When pressure is increased, the gas molecules move close together, resulting in an increase in the frequency of the effective collisions. Therefore, the rate of the both forward and backward reaction increases. So this is the point which you have to remember.